Hey, algebra fans, Mrs. Lindsay, back again to talk to you about factoring trinomials. Were you thinking yesterday that things might be a little too easy? Things might get a little bit harder? Well, you were right. I'm here to talk to you about factoring trinomials with a lead coefficient greater than 1. That lead coefficient we call A, and if that lead coefficient is greater than 1, things get slightly more complicated. So let me go away and we'll have at it. If you remember, yesterday we talked about x squared plus 2x minus 3. If your lead coefficient or your a was equal to 1, it was just a simple matter of finding two numbers that added to 2 and multiplied to negative 3. So two factors of negative 3 that added to 2. First, we split the x squared into x and x. That was relatively simple because the lead coefficient was 1. Now, your two factors of negative 3 that add to 2 were negative 1 and 3. You place them in any order in the two binomials, and there you have your answer, x minus 1 times x plus 3. Easy, right? So what happens if I maybe switch the 1 and the 2 around? What if I make the 2 my lead coefficient? Now I have a problem. First thing I have to do is find two numbers that multiply to negative 3 and add to 1. Well, guess what? There aren't any. But not to fear, 2x squared is not going to get split up as x and x. It's going to get split up as 2x and x because I need to get it to multiply to 2x squared. Well, that complicates things. I need two numbers that add to negative 3, that add to 1 and multiply to negative 3, but one of those two factors is going to get multiplied by 2 first. Remember in FOIL, the outside terms multiply together? So this 2 is going to get multiplied all the way over here to this factor of 3. One of these two factors gets multiplied by 2 before I add it. Let's try it. What if I multiplied 2 times 3 before I add it to the negative 1? Would that give me my desired middle term of positive 1x? Well, 2 times 3 is 6, minus 1 is 5, so sorry, that's not going to work. Let me try something else. What if my two factors were negative 3 and 1, and I multiplied my 2 times the 1? Well, negative 3 plus 1 times 2, that's so close. That gives me a negative 1. I really wanted a positive 1. If that happens, it's a pretty simple matter of just switching the signs. So I'm going to switch the negative from the 3 to the 1. So instead of a factor of negative 3 and positive 1, I'm going to have factors of positive 3 and negative 1. Remember, the negative 1 has to be the multiplier of 2, so my negative 1 needs to go into this binomial, and my positive 3 needs to go into this binomial. So now I have it. 2x times negative 1 is negative 2x. Positive 3 times x is 3x, and that adds to 1. Finished. Those are my two binomials that multiply out to 2x squared plus 1x minus 3. That's kind of confusing. The box makes everything simpler. Just as the box made FOIL simpler, the box is going to make factoring simpler, especially when we have a lead coefficient that's greater than 1. So let's try it. Here's my box. If you remember, when I multiplied out my two binomials, when I multiplied my first terms, that number went in the upper left-hand box. When I multiplied my last terms, that number went in the lower right-hand box. So I'm going to arrange those in the box right now. 2x squared and negative 3. Upper right, upper left, lower right. These two boxes were the two that were like terms and added to positive 1. Problem is, what are they? Again, I can't get two numbers that multiply to -3 and add to 1, but let's say I multiplied my lead coefficient and my constant first. So if I multiply A times C before I try to see what adds to +1, that might work a little bit better. So instead of fishing around to find which factor multiplies by 2, I'm going to multiply it right away. So 2 times -3 is -6. I need to find two numbers that multiply to -6 and add to 1. Well, if you can't find them, you can always take out your calculator, go to the y equals -6 divided by x, go to your table. You're going to find all the factors of -6 that you can imagine. All I need are the two factors that add to my middle term, +1x. +3 and -2 add to +1. And again, I'm going to write them as x terms because I really want them to add to 1x, which is right there. And now all you need to do is arrange them in the box. It doesn't matter which order you put them in, because right now, all I need to do is factor all my GCFs. I'm going to factor along the columns, and I'm going to factor along the rows to fill out the sides of my box and the top of my box. So 2x squared and 3x have a GCF of x. -2x and -3, well, they don't have any GCF, but I do have this negative here in my lead coefficient that I need to get rid of. So what I'm going to do is when I factor, I'm going to factor a -1. That'll make this lead coefficient positive, and I don't have any other factors of 2x and 3. So I'm going to factor out a -1 because that -2x is negative. Now I'm going to go along my rows. 2x squared and -x, my GCF is 2x, and 3x and -3, my GCF is 3. Now I have my binomials. Here are my two bubbles, my two binomials. 2x plus 3 is one of them, and x minus 1 is the other. And there I have my factored form of 2x squared plus 1x minus 3. As easy as that. Let's try another. I like the box method, and I'm going to keep that up. Anytime I have a lead coefficient, I'm going to use the box method. So my lead term, 2x squared, and my constant go in the upper left and the lower right. There they are. My other two boxes are going to be the like terms that add to 7x. So I need two numbers that add to 7x, two terms that add to 7x. How do I get them? Multiply the lead coefficient and the constant, the 2 and the 3, or a times c, and I get 6. So I need two numbers that multiply to 6 and add to 7. If I know what they are, great. If I don't, I can always use my calculator. 6 divided by x and the y equals. Look at your table. I'm looking for two factors of 6 that add to 7, and there they are, 1 and 6. I write them so that they add to 7x. So I have 6x plus 1x, and it doesn't matter which order I put them in the box. Either way, there they are. Now all I have to do is find my GCFs. So looking along the columns, 1x and 2x squared, my GCF is x. Along this column, my GCF is 3, so x plus 3. Along the rows, my GCF is 2x. And 1x plus 3, there is no GCF, so I'll just have to write a plus 1. There I have my binomials. Along the columns, 2x plus 1. Along the rows, x plus 3. There's my factored form of 2x squared plus 7x plus 3. two binomials. Let's give it one more try. I have 2x squared plus x minus 6. Here's my box. Lead term and constant go in the upper left and the lower right. These two boxes are going to be the like terms that add to x. First, I'm going to multiply my lead coefficient times my constant. 2 times negative 6 gives me negative 12. I need two numbers that multiply to negative 12 and add to that 1. If you don't know what they are, go to your calculator, y equals negative 12 divided by x, and look down your table for two factors of negative 12 that add to 1, 4 and negative 3. You can rewrite them as 4x and negative 3x and arrange them in your box. It doesn't matter what order. All I need to do now is factor all my GCFs. 2x squared and 4x have a GCF of 2x. And negative 3x and negative 6, remember, if we have a negative lead coefficient here, I have to factor out a negative. So I'm going to factor out negative 3. Along the top, I have 2x squared and 3x. I don't have a negative lead coefficient here, so my GCF is x. And I don't have a negative lead coefficient here, so my GCF is positive 2. So there it is. Along the rows, 2x minus 3 goes in one of the binomials, x minus 2 goes in the other binomial, and there I have factored form 2x squared plus x minus 6, two binomials, 2x minus 3 times x plus 2. And there you have it, ladies and gentlemen. Easy way to factor trinomials with a lead coefficient that's greater than 1. I'll see you tomorrow. If there's any questions, we'll do some more practice and talk about it then. See you then. Have a great night.